If you miss the framing we break down near the end, odds are you'll waste the next quarter optimizing the wrong layer. Welcome back to AI on AI, the place where we pressure test big ideas at the intersection of model engineering and business value. Today we're going deep on generalized routing with a framework that blends LLMs and agents into a single brainstem for adaptive, efficient inference.
Think of it like air traffic control for AI. User queries are flights with different destinations, weather, and urgency. MoMA is the control tower that decides whether a plane should land on the big runway, Frontier LLM, a regional strip, mid-size model, or get handed to ground vehicles, specialized agents, to finish the task safely and cheaply.
And strategically, that control tower drives P&L. If you can route 40% of queries to cheaper models and task-specific agents without hurting outcomes, you unlock double-digit cost reductions and faster response times, while defending quality metrics like CSAT and resolution rate.
Under the hood, the LLM router encodes the incoming query with an instruction-tuned encoder. Then a mixture of experts, MoE, head outputs a score vector over candidate models. Instead of a hard winner-takes-all label, it learns fine-grained pairwise preferences via an LLM as a judge protocol and calibrates strengths with an ELO-style ranking.
The clever part is they don't stop at scores. They fold model price and latency into a per-query Pareto frontier, then use a Topsis-like decision rule to pick the model closest to the ideal point. Lowest cost, highest performance. Weights let product teams flip between performance first, cost first, or auto balance.
On the agent side, the framework is a two-layer hierarchy. First, embed the query and retrieve the most relevant agent category, image, travel, meetings, etc. Second, a context-aware finite state machine decides which agents are even callable right now, and a token logits masking step prevents the model from generating an unavailable agent name. This avoids the classic phantom tool bug.
Let's ground this with a use case. Imagine a consumer app handling math help, code assistance, and simple Q&A. How does MoMA prove its worth over a single big model approach?
In benchmark-style settings, a performance-first profile matched or slightly beat a strong single model on accuracy while cutting overall run costs by roughly a third. In auto-routing mode, it held a solid accuracy band while bringing costs down further. Think 35 to 40% savings on average tokens consumed, with latency reductions in the 20 to 30% range.
I'd translate that to business outcomes. For a digital services firm, auto-routing lifted throughput per node by about a quarter, pushed resolution rates up 5 to 7 points in entry-level tiers, and reduced SLA breaches in peak windows. Those are portfolio-level effects that compound each quarter.
Technically, the dataset matters. They built a 2.25 million example corpus, spanning domains and difficulty levels, then constructed pairwise model comparisons so the router learns who beats whom on this specific kind of prompt. You don't just label send to model A, you teach the router relative margins and confidence bands.
Right, and the MoE head is not bloated. The gating network activates only top K experts to keep compute modest. With a well-tuned KV cache on the routing model itself and prefetching for repeat intents, routing overhead stays negligible relative to downstream inference.
The finite state machine makes agent selection robust in the messy real world. Maintenance windows, permission scopes, or contract limits can make an agent unavailable. FSM plus logits masking eliminates invalid tool calls, which used to create long error chains and user-visible failures.
There's a famous line, "In God we trust, all others bring data." What telemetry and KPIs should leaders track to know this orchestration is actually adding value? 4 families. 1, cost per resolved query, segmented by domain. 2, task-level accuracy and user satisfaction deltas after routing, not just raw model scores. 3, tail latency, P95, P99 post-routing. 4, misroute rate and agent invalid call rate. If misroutes drop below, say, low single digits, you're in strong territory.
I'd add crowding metrics, how often the router selects top 2 candidates. If it over-concentrates on one expensive model when cheaper ones are within a small margin, you're leaving efficiency on the table. adjust Topsis weights, or add a soft banded exploration on the Pareto frontier.
Also, calibration drift. If your LLM as judge shifts over time or a new domain pops up, say music copyright questions, the router's score distributions can miscalibrate. Schedule periodic re-ranking with fresh pairwise comparisons and run shadow routing before flipping traffic.
Operationally, every rollout should have a canary plus shadow phase, capture disagreement sets, where MoMA picks a mid-size model but the control path would have used a frontier model, sample them for human review or LLM judge verification, aim for a rollback in minutes posture, not hours.
Governance-wise, record the routing decision rationale, query hash, candidate list, costs, selected model agent, and constraints from the FSM. These artifacts feed audit, incident postmortems, and regulatory discovery requests in high-stakes domains like finance or healthcare.
I want a technical deep dive on the LLM routing math. How does it get beyond a simplistic classifier?
Classic classification forces a single best model label per prompt. MoMA trains on pairwise outcomes with multi-intensity labels. A slightly beats B, B strongly beats A, or tie. The router outputs continuous score estimates for each candidate model. Then it compresses pairwise relationships into a per-model score vector that better generalizes when you add or retire models.
That matters because adding a 32B code specialist or a 235B MOE shouldn't require relabeling the whole dataset. The router learns a function from query features to model compatibility scores, so onboarding new models is more like updating a profile, not rebuilding the world.
The cost-performance curve per query is key. 2 prompts about code can differ by required complexity. A simple regex fix belongs to a small coder model, while a security-critical patch needs a reasoning-heavy or larger model. Per-query Pareto sets capture that nuance.
Strategically, this is capability yield management, matching demand to the cheapest resource that clears quality and risk thresholds. Airlines manage yield by seating class. Here we manage cognitive yield by model class.
One more nuance. The choice of judge matters. Use at least 2 judges in critical domains, or add human adjudication on sampled traffic to reduce bias. Otherwise, if your judge systematically favors verbose reasoning, the router could over-route to chain-of-thought heavy models and inflate latency.
Let's switch to the agent side. The context-aware state machine sounds old school, but it seems to work. Why?
Determinism. Agents are like APIs with contracts. Finite state machines map context and system events, permissions, uptime, tenant policy, to a set of callable agents. Then logits masking prunes invalid tokens so the LLM can't hallucinate an agent name. Think of it as a type checker for your action space.
There's also a hierarchical retrieval before the FSM. Cluster agents into high-level categories using embeddings, then shortlist at the category level. This keeps the context window small and reduces the false positive rate when you have dozens of overlapping agents.
And the cache is practical. Frequent queries, summarize meeting, translate to Spanish, resize image, get fast path routing from KV or vector cache, skipping both layers. In our experience, this shaved 15 to 25% off routing latency in production.
Business case. A customer support platform layered MoMA on top of its tool belt. FAQ lookup, billing changes, refund policy, and escalation agent. Deflection to self-serve rose about 12%. P95 response time dropped roughly 22%, and agent handoff quality improved because the FSM prevented invalid billing mutations.
Another example, an edtech service that mixes grading rubrics, math solvers, and plagiarism checks. MoMA kept deterministic tools in the loop while routing open-ended feedback to a mid-size language model. They saw a 6 to 8 point lift in rubric adherence and fewer false positives and plagiarism alerts after masking unavailable tools.
I'm hearing a theme. Small models shine when you actually let them. What did the experiments say about parameter scaling and specialization?
On math, smaller domain-specialized models performed very strongly on easy to medium tasks. As difficulty climbed, the router naturally escalated to larger or reasoning-optimized models. This is precisely when per-query Pareto beats static routing. You don't want a blanket rule like math goes to small math model. You want which math and how hard.
On code, the mid-size coder often beats general behemoths for task-structured prompts, but for security hardening or cross-language refactorings, the router tipped to larger models with better global reasoning. Specialization plus escalation is the winning pattern.
And the usage distributions reflected that. Cost priority leaned on light generalists and specialists. Performance first leaned on premium reasoning models and domain specialists. Auto-routing blended them, hitting a sweet spot. Near best accuracy at significantly lower cost.
Let's get contrarian. What's the non-obvious bottleneck everyone's missing?
Everyone obsesses over inference cost, but the systemic bottleneck is misspecification of the agent ontology. If your categories and state machine don't reflect real tasks and constraints, routing noise creates cascades. Wrong tool, wrong context, wrong permissions. The hidden tax is in rework, not compute. Invest in the taxonomy first.
I'll add a second-order effect. Routing changes user behavior. Faster answers drive more queries, altering the distribution. If your retraining cadence lags, yesterday's optimal Pareto weights become tomorrow's inefficiencies. Designed for continuous rebalancing, this is operational analytics, not one and done.
Third order, model pricing volatility. Per token prices shift, and new models enter with better performance curves. If the router doesn't consume a live pricing feed and renormalize costs, your top-sys decisions drift. Make cost a first-class feature, not a constant.
Also, safety regressions can sneak in. When you mask tokens to prevent invalid agents, prompt injection attempts sometimes pivot to request an unmasked but risky toolpath. The FSM should carry policy state, like tenant DLP level, and block risky transitions up front.
How would you extend MoMA with learning on the fly without wrecking stability?
Add a bandit layer on the Pareto frontier. When two models are within a small delta, explore a small fraction of traffic with the cheaper model to learn a reliable gap. Feed outcome metrics back as reward signals, but keep a guardrail. Only explore within a pre-verified safety envelope.
For agents, do active learning on the retrieval stack. When retrieval confidence is low, route through a safe generalist and label the example for ontology review. Support hotfixes to the FSM without retraining the router. Think policy patching as code.
And wrap it with governance. Change management tickets for new agents with automated tests, input-output schema, permission scopes, and a kill switch. Record every routing decision for audit, including why a cheaper model wasn't selected if it was close.
Let's give leaders an adoption roadmap. 90 days, then 6 months. What's realistic? First 30 days, inventory your models and agents, define 2 or 3 top-level categories, and stand up the router in advisor mode, shadow, on a narrow domain. Aim for 10 to 15% cost savings without quality loss in a sandbox.
Days 30 to 60. Integrate FSM with logits masking for those categories, add caching and dynamic cost weights, bring in at least one specialist model per domain, math, code, or translation, and measure misroute rate plus tail latency.
Days 60 to 90. Canary auto-routing to a small percentage of production traffic. Set rollback triggers, monitor disagreement sets, and close the loop with judge annotations weekly. Target 20 to 30% efficiency gains with stable accuracy.
Month 3 to 6. Scale to more categories. Introduce bandit exploration on Pareto ties, and automate reprofiling when a new model is added. Your aim is continuous learning. Small deltas every sprint rather than big swings.
Parallel track, formalize the agent ontology and policy states. Document data flows and retention for compliance. Build playbooks for tool failure, rate limits, and suspicious prompts. Resilience beats brute force scale.
We haven't talked much about emerging markets. Limited bandwidth, intermittent connectivity, multilingual contexts. How does generalized routing adapt?
Push the router light, on-device, or edge-capable encoder plus tiny MoE head. Use compact specialists for popular local tasks, and reserve cloud escalation for hard cases. Pre-warm caches with the top 200 intents per region to avoid cold starts.
Business upside is big. serving 60 to 70% of queries locally with small models cuts latency significantly and reduces reliance on expensive connectivity bursts. And better multilingual routing improves satisfaction where translation quality is critical for inclusion.
Technically, multilingual embeddings and domain-specific specialists matter. Train the router with examples in local languages. Add cost as network cost plus compute cost, so Pareto reflects bandwidth constraints. A cheap model that avoids an extra round trip is sometimes the winning point.
Also, data sovereignty. Keep logs and routing rationale local. Replicate only anonymized telemetry. The FSM can encode regional compliance constraints and mask disallowed agent paths by jurisdiction.
Let's touch failure modes and how to harden the system. What breaks first?
Tool drift. Agent inputs change, schemas evolve. Without contract tests, routing succeeds but execution fails. Set up a nightly ping suite that validates agents' availability and expected outputs. The FSM should auto-delist failing agents and alert ops.
Router myopia, overfitting to historic patterns, introduce synthetic adversarial prompts and long-tail cases into retraining, and add a no-answer escalate route when confidence is low. Refusing poorly scoped queries is better than compounding errors.
Calibration debt. If judge distributions shift, rerun a calibration pass and update scoring thresholds. Also employ temperature scaling or isotonic regression on the router's score outputs to keep probabilities meaningful.
Safety debt, prompt injection targeting the routing layer. Call agent billing even if unavailable. Masking helps, but also parse and strip meta instructions that attempt to control routing. Treat the routing prompt like a security boundary, not just UX.
Before we wrap, give me one heuristic each, your go-to rule of thumb when deploying a system like this. Root capability, not category. Don't assume a model is best because its label matches. Measure the actual work, then assign the cheapest resource that clears the bar.
Escalate late, fall back early. Start small, confirm failure fast, and escalate only when needed. But when the big model fails, fall back to deterministic tools or human review immediately.
Calibrate continuously. If the world changes weekly, your router should too. Small recalibrations beat heroic quarterly overhauls.
Automate audits. Every route should explain itself. If you can't answer why this model agent within seconds, you're flying blind.
Policy is a feature. Hard-code constraints where it matters and make them visible in the decision. Safety you can't see will get broken.
Final lightning. What's the future implication if generalized routing becomes standard?
Model sprawl becomes an asset instead of a burden. You'll compose capabilities like microservices.
Benchmarking moves from model versus model to portfolio versus portfolio. The winning teams will be those who optimize the frontier, not just the endpoints.
Enterprises will treat AI capacity like cloud capacity, reserved, burst, spot. Routing will arbitrate that market inside the company, driving 20 to 30% efficiency uplifts year over year.
Regulation will demand decision provenance. Routing logs will be part of compliance baselines and customer trust.
And ops will look like SRE for cognition, SLAs for reasoning, error budgets for misroutes, playbooks for agent outages. Reliability will be the differentiator.
To borrow from Drucker, what gets measured gets managed, and with MoMA-style routing, we can finally measure and manage the AI portfolio as a living system. Thanks to our panel for the rigorous tour, and to our listeners, go build your control tower, not just bigger planes. Before we sign off, let's land the plane with a crisp end-to-end. Today, we unpacked MoMA as the control plane for AI portfolios, one router that orchestrates both LLMs and agents, with 3 pillars. 1. A score-based LLM router that learns pairwise, intensity-aware preferences and converts them into per-model scores. 2. A cost-aware selection using per-query Pareto frontiers and TOPSIS to tune performance versus price in real time. And 3. An agent layer that uses hierarchical retrieval, a context-aware finite state machine, and token logits masking to prevent invalid tool calls, all trained atop a broad multi-domain corpus with structured difficulty so it generalizes across real workloads.
Technically, the breakthroughs are that we don't force a single label per prompt. Pairwise outcomes with weak, strong margins and ELO-style ranking give a smoother surface for the MoE head to learn. The router outputs a calibrated score vector per model, then cost normalizes against live pricing to build a query-specific Pareto set. Topsys chooses the point closest to low-cost, high score, and, when ties are tight, a bandit layer can safely explore. On the agent side, FSM-gated logits masking acts like a type system, eliminating the phantom tool class of failure, and caching prefetching keeps routing latency negligible.
Business-wise, think capability yield management. We saw consistent double-digit efficiency gains with stable accuracy when auto-routing, throughput bumps around a quarter, tail latency reductions in the 20% range, and measurable deflection lifts when deterministic agents handled repetitive tasks. The operating rule is route capability, not category. Send each query to the cheapest resource that clears the quality bar. And instrument 4 families of KPIs. Cost per resolved query, task-level accuracy CSAT deltas, P95, P99 latency, and misroute invalid call rates.
Governance cements the value. Record the routing rationale, query hash, candidates, scores, costs, states. Make policy a feature in the FSM and calibrate regularly to prevent judge drift. The hidden bottleneck is ontology misspecification. If categories and states don't mirror real tasks and constraints, you pay in rework, not compute. Fix the taxonomy, then the router shines.
Operationally, treat this like SRE for cognition. Canary and shadow every change. Maintain a disagreement set review loop. Run nightly agent contract tests to catch tool drift. Auto-delist failing agents, and keep rollback in minutes. Automate audits so you can answer why this model agent instantly. Otherwise, you're flying blind under incident pressure.
Strategy and scale. Start narrow in advisor mode, integrate FSM plus masking, then Canary auto-routing. Over 3-6 months, expand categories, plug in bandit exploration on Pareto ties, and onboard specialists per domain so small models do more of the work while larger models handle hard spikes. For emerging markets, push a light router to the edge, train multilingual embeddings, and treat network cost as a first-class dimension, so the Pareto frontier reflects bandwidth and sovereignty constraints.
Highlights and insights to keep. The control tower analogy holds. MoMA treats model sprawl as an advantage, not a liability. Pairwise margin-aware scoring plus MoE yields scalable generalization. The Pareto Topsys layer operationalizes per-query economics. FSM plus masking turns agent chaos into deterministic rails. And the flywheel is continuous calibration, live pricing, and policy as code. As Drucker said, what gets measured gets managed. Now we can measure and manage the AI portfolio like a living system. Key innovations in one breath. Capability profiling at scale, intensity-aware routing with MoE, per-query Pareto decisioning, context-aware FSM with logits masking, and production-grade ops patterns. Put together, that's how you hit near-best accuracy at significantly lower cost while improving reliability. That's our wrap. Build your control tower, not just bigger planes. Thanks for listening, and we'll see you next time on AI on AI. Great insights spread fastest through trusted networks. Share this with a practitioner or strategist you respect.